afternoon and welcome to Tech Talk 4, Tech Careers in Advanced Manufacturing and Aerospace, presented by Will Shrapnel from Helimods. The Tech Talk series is brought to you by the Australian Computer Society, the ACS Foundation and the ICT Gateway to Industry Schools program. The Information and Communications Technology Gateway to Industry Schools program encourages partnerships between industry, government, schools and the communities to build Queensland's future information technology workforce. The Gateway program is proudly supported by the Queensland Government. My name is Geraldine Pan and I will be your host today. I am an intern at the ACS Foundation and I am currently studying a Bachelor of Games Design and Development at Macquarie University. In the spirit of reconciliation, ACS acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to the elders past, present and emerging and extend that respect to all Aboriginal and Torres Strait Islander peoples today. This series of webinars is designed to provide information for parents, students, career advisors and teachers about careers in the tech industry. Each presentation will last 25 minutes, followed by a 10-minute Q&A session. Please use the Q&A function to submit a question for the presenter. Don't forget to include your name first and then add the question. Our guest presenter for Tech Talk 4 is Will Shrapnel from Sunshine Coast-based Helimods, a globally recognized award-winning aerospace technology specialist with a reputation for excellence and innovation. Will is an engineer, fixed-wing and helicopter pilot, aircraft technician and businessman who founded Helimods in 2002. Helimods is committed to engaging with the community to build technology capability in local students and increase the numbers of potential local tech employees. Over to you, Will.
Great. Thanks, Gigi. I'll just get my screen up here now. All right, so to the thousands of young students and parents out there listening today, I'm going to be talking about tech careers in advanced manufacturing and aerospace. So I guess just to kick off, we're living in a world that's changing and changing fast. So we absolutely have now a combination of options in career and future that really are unprecedented, I guess, as we look forward as to what might be out there in the future. A little bit about my background. As Gigi said, I founded Helimods in 2002. I spent a fair bit of time actually skilling and educating and really trying to get the right qualifications for the sort of work I really wanted to do. For me, that was a Bachelor of Mechanical and Aerospace Engineering. I also did a Bachelor of Business Management in Business Economics. I'm a licensed aircraft maintenance engineer, so I have a technical and trades background as well. And I guess as someone that's always had a thirst or interest in machinery, technology, and the like, I've through time acquired helicopter and fixed wing licenses. So my background, probably importantly from very early on, was really about designing, building and flying model aircraft. So I guess that was the first taste I got of an advanced manufacturing and aerospace industry, if you like. And I guess that shouldn't be considered lightly. I mean, the experience we get as kids, as young adults in doing the things we love doing, whether that's related to technology or different sciences or other different industries, it's some of the most important formative work you do. So I guess further to that, I spent a lot of my young life and student life using and applying technology to solve problems. So something that's always been really important to me is sort of trying to not just solve a problem, but use technology wherever possible to make things better or improve on things. So I guess what I discovered at a fairly young age was that developing knowledge and hands-on experience was a worthwhile use of time. I mean, it's something that I love doing, and I guess the more I practiced and the more I applied knowledge, you know, the more challenging problems I could solve. So then, as a high school student, really was aiming to align my education with my areas of interest. Look, I can speak a little bit more about that later on in the talk, but I guess that's sort of the background to how I really got involved with aerospace and advanced manufacturing, and then what led me to be in a position to start up the business known as Helimods. So I guess here today we are a globally recognised and renowned aerospace tech company. We've got world-leading capability in advanced digital design, manufacturing, certification, integration, and support of aircraft mission systems. So from really quite humble beginnings as a kind of technical guy, I guess, that really enjoyed the understanding complex machines like helicopters, my career really progressed quite quickly into understanding how to solve problems on helicopters, and then really, as really referenced before, understanding how to use technology to solve those problems and really add some value in a market. So importantly for this talk today, I guess thinking about Industry 4.0 and the digital twin, those of you out there now, whether your parents, students, teachers, we hear a lot about the fourth industrial revolution, and I guess, you know, in different contexts, referenced commonly now. But look, I guess the best way I can aim to describe that is really the combination of big computing and big data on one side, with big networks with a whole lot of bandwidth on the other side, and then really the transformational progression of engineering in the middle. So what you see there on my slide deck there now is an image of inside our facility here at the Sunshine Coast. So you see a large helicopter asset there, which, you know, we can be familiar with as a tangible thing or tangible machine. But I guess really importantly, digital engineering, what that lets us do is really understand that physical object in a digital definition. So what's just popped up there is really a reference to our digital twin of that aircraft that sits behind. So really, for the fourth industrial revolution, if we think about those combining effects of big data, big computing, big networks, and then really that transformation of engineering, we're thinking about how we traverse between those digital and physical worlds, and how that happens in engineering, how that happens in advanced manufacturing. So it's a really exciting time, because I guess in engineering now and the technology that supports it, we have access to all sorts of opportunities that are global by leveraging and progressing our digital definition of things. I'm going to run through some examples in this talk as to how we might do that. But I guess if you note that some of those images there behind, we'll have a look at what that looks like now in context. Now, for those of you out there that are into gaming, or particularly in the 3D, flying around in the 3D world or simulated environments and worlds, you can see what's behind there is our digital twin of a particular helicopter, the AW139. We've got that now referenced up for some potential capability out of New York for the NYPD. The NYPD right now is trying to understand their options for certain capabilities in the market. We're able to use our reference of the digital twin we have to present options in a digital realm, or really like a 3D realm, to the NYPD to share and explain what things might look like. Now, this is well before we have to build a physical object. So I guess that's where now, with technology where it's at, we can do engineering work all over the world. So what that would look like in the field is some of our engineers or some of our technicians working with the NYPD end users. You can see there we've got augmented reality headsets. We're dropping those guys into seats and actually showing them what an environment might look like around them in a potential new helicopter. So really those immersive environments that that the ICT space is familiar with from a gaming context. Now they mix more and more with the end users of real technologies, and I guess then we sort of get, you know, we get this combining of that digital and physical world in technologies like augmented reality. So then to give another sort of physical example of that, I guess, this is that same type of aircraft, which is an AW139 helicopter that's sitting on our flight line here at Caloundra. Aircraft come from a manufacturer as a fairly empty, fairly empty or basic configuration, and it's a specialist job to get those aircraft mission ready. That's the sort of work that we do here at Helimods. So if we look at something like a mission cockpit, we've got, for flying a helicopter, there's quite a few instruments and aspects of a panel that are important. When we start doing mission work on a helicopter, we really want displays that are suitable for surveillance or observations or other tactical roles. So in doing that design work, we do a lot of work in the digital space to simulate environments. We also do a lot in the software space to think about how we actually can add situational awareness or views or options for tactical officers that might fly an aircraft like this. So you'll watch the screen there now just merge out from some of our digital overlays that let us simulate displays, test things like ergonomics or reach. They're examples of the sort of imagery that we can provide through augmented reality or virtual reality. So I guess, again, that simulated environment that we're familiar with more so in the gaming space becomes a really important tool when we're trying to represent what aircraft capability might look like. So if we look in the back of a helicopter like that, where a lot of the sort of work on a tactical machine is done, you see there a large mission workstation. As I previously referenced at our Big Day In talks, that's a very large and expensive in-aircraft computer for doing specialist type of specialist roles and specialist work. So that is like the office of a tactical flight officer. It's got a lot of communications. It's got a lot of options for viewing sensors and really gaining a whole lot of situational awareness and mission awareness. So if you like, that's like a really large game in the back of the aircraft, but it's doing real work. So that workstation is something we would develop internally here. That starts for us really in the 3D and CAD environment. So that's making, you know, really accurate digital models and of what a product might need. So from requirements right through to then some of the geometric positioning of these objects, really building up then a high fidelity definition of a product, which we'd call really a product digital twin, that lets us progress that design really to up to manufacturing stage before we've actually produced any physical objects. So I guess just gives you an idea of the level of simulation in advanced manufacturing and aerospace is high, and we progress designs a long way in the digital domain before we make physical objects. So what that looks like at a workplace like Helimods is really a lot of technology, a lot of computing capacity for doing simulation, for doing modeling, for doing all sorts of analyses, whether they're in engineering or in other domains like software. So I guess it's really using every technology that's available for us at our disposal to carry out the important work we do of mission systems integration. Our engineers are pretty experienced users of augmented reality, so we're a Microsoft HoloLens developer. We've got our own apps that we run internally and for our customers to let them really interact with aircraft configurations and all sorts of mission equipment in the digital world, usually placed in a real helicopter at the early stage of a program and then developed physically through time. So again, using that workstation example that we previously had displayed, this is some of our engineering team really aiming to test some of the ergonomics and operator comfort and things like that for that particular mission station. That work can naturally be done in the 3D environment, so we can run anthrometrically correct digital models, so we can really check for all of those things in the simulated environment, and then we can validate those physically. Speaking, I guess, before of again, fourth industrial revolution and really the evolution of manufacturing, and I guess we've heard a lot about 3D printing. Look, importantly, that domain of additive manufacturing is progressing very quickly. So conventional manufacturing is most usually subtractive, so we remove material from a raw billet or a raw chunk of metal to then reduce its volume. In the additive space, we're 3D printing. Now, if you have a digital definition of a thing, that's obviously portable across borders and to different offices and different locations. So you can print prototypes quickly as materials progress in 3D printing and additive manufacturing. The additive space will be dominant over the subtractive spaces before long. And so really that requires a whole lot of back end of technology to develop those digital models. That's really what traditional subtractive manufacturing looks like. Now, even in subtractive manufacturing, you still want to generate your digital definition of a part or an object before you manufacture it. So that's one of our machines at our facility, and one of our engineers really checking on that component in a simulated space as we're making the real physical object. So I guess that space, computer-aided engineering, computer-aided manufacturing, is really interesting for young people that like making stuff and know how to use computers or run simulations or are interested in automation, because essentially the CNC machines are computer numerically controlled machines, so they need to be programmed. When we consider a new product, whether it's hardware or software, we develop those products in-house. So we're using the digital data to inform what that production is going to look like. Our engineers that develop those products will most usually manufacture the first of type so that they can check the components that they've designed match their intent for how that goes together. So you see there one of our young engineers assembling a product that she has developed in the 3D environment, and she's doing really a physical verification of that to check that goes together as planned before that might be then integrated into the aircraft. So I guess then all of that work then comes together in then what would be in our environment flight testing of finished products, again hardware and software, but then all brought together in the context of an aircraft that's going to go and perform special missions. We've got to do flight testing in and around that, so we get to do some pretty cool work with end users and operators to make sure what we've designed really does exactly what it needs to do and can meet all the design standards it needs to comply with, so it can fly safely and effectively for years to come. That then ends up with, I guess, an aircraft that's fully mission integrated, if you like. It's got all of its systems and equipment and sensors combined to generate now really a mission effect or a total mission capability. That's an aircraft that's on our flight line here at Caloundra from last year during a final night flight test phase, really just a short while before it completed its certification and then headed down, in this case, to Police HQ in Melbourne, Victoria. So I guess you can see there a really quite a rewarding program of work. That was a large job for our team that occurred over probably around about 1.5 to 2 years total. Really rewarding work to see an aircraft and a capability like that go online. What I really want to then, I guess, speak to here for this audience is really to touch on some of the benefits of tech careers, really, or what tech career pathways look like in our industry, which is really aerospace and advanced manufacturing. So I guess benefits of a career in tech, well look, really that's becoming more and more obvious, I guess, to those that are involved with virtually every industry now, that tech is really immersive in all things, but most certainly in aerospace and advanced manufacturing, there's so much rapid change in our environment. So I guess a career in tech is a secure future career. Historically, we would have looked, say 10 years ago, we would have been looking toward engineering graduates in aerospace, or maybe electrical, maybe mechanical. Whereas I guess now that with more immersion of tech and digital industries upon us, our software and tech teams are now really growing, probably even at a greater rate than our engineering teams, but certainly there's a lot of crossover in those domains for us. So the benefits of a career in tech, it's pretty obvious in our domain. There's going to be more and more demand for technology in a digital simulation sense, or a programming sense, or automation sense across advanced manufacturing and aerospace. Now, to touch on some of the study pathway examples, I guess then commonly I'm asked, well, what should students study? I think really the most important thing there is for students to aim to study what they're passionate about, aim to study what they love doing first and foremost. And look, even if you love doing something and you're not necessarily great at it, there's a whole lot of value in practicing and refining those skills, or gaining knowledge in and around things that interest you and things that you're good at. So really, that's a quite a broad question, really, where I aim to answer that to say students should study what they really enjoy doing first and foremost. Now then, I guess following on from that, do school results matter? Well, it's again another question that I get. The school results, and tertiary results or trade school results, well, they do matter because they really show what a student is good at, or what they're applying themselves towards. They may not be everything. I mean, an applicant for a role or a career here really needs to demonstrate that they're passionate about a technology or a domain, whether that's they love programming, they love automation, they love simulation, maybe broadly engineering, whether it's analysis or building physical things or designing things. They're really the school results or tertiary results can give a pretty strong indication of how well an applicant's applying themselves to their study, how engaged they are with learning. And really, for an industry like ours, we're interested to create careers for people that want to learn, people that want to grow their skills, grow their knowledge, and really use those skills to solve challenging problems. So that's sort of what works for us. Technical versus practical skills. Now, my own background, I guess I had a strong interest in theoretical knowledge as well as practical knowledge. So I probably had a bit of a unique circumstance there where I progressed trade type studies in parallel to tertiary type studies. I really grew up as a more hands-on type of technician, I guess. But then I found that technical or theoretical skills and practical skills combined have been a really strong asset for me. So look, in a ICT domain, that really means getting hands-on with programming, hands-on with automating things, really from the earliest possible chance. I would encourage anyone to practice and hone their skills. So I guess if I look at career pathway examples, that's things like the conventional things like work experience, traineeships, internships, and graduate roles. I can really touch on those very briefly, but most importantly for young students and students looking to progress their education, their career, don't underestimate the value of practicing and honing and refining your skills, both in a school context or an extracurricular context. One of the things we really look for in applicants through some of our programs here is demonstrated interest and knowledge, or developing knowledge in extracurricular areas. So if you're into gaming and you're into programming or into things like that, don't be afraid of expressing how you've developed those skills, how you've actually used or refined those skills through practice, and don't be afraid to give examples. So look, we run here at Helimods work experience programs. That's really to give school kids or tertiary undergraduate students just some exposure to what we do here day in, day out. Traineeships, they can be anywhere from advanced manufacturing type future trades to technical roles that could be at a on-the-job type training of computer and network type skills, right through to pretty advanced software engineering or electrical engineering, mechatronics engineering, things like that at a tertiary sort of a setting. So look, really there's no single pathway there. That the tech careers are very diverse, and more through time, that's really going to be reliant on workplaces like ours to identify talent that's prepared to invest in education and skilling to really apply themselves to challenging and rewarding roles and careers. So equivalently then, internships where there are students that have progressed through into tertiary studies and are interested in maybe future work here, we do tend to aim to bring them back in through our environment to get some more detailed and hands-on work experience through internships. So they can be over summer breaks and things like that. And then hopefully they lead to then graduate roles, which are, really so much of our future growth is in and around the graduate roles. So, and they are, like I mentioned earlier, they are broad and diverse. So that would be graduates in the ICT spaces, computer science, programming, a whole range, even digital media and marketing, things like that are more and more part of doing everyday business. So I guess that sort of gives a bit of a cross section there now of really what a tech career pathway looks like in advanced manufacturing and aerospace. And I believe now, Gigi, we've got some Q&A to run. Whether I want to hand over to your screen, let me know.
Thank you for that presentation. We now have some questions for you. Do you have open days for kids?
We tend to attend careers fairs or things like the Big Day In, school careers fairs at times. Right now we don't have any open days, but we are attending typically jobs or careers fairs. So certainly through ACS, anything that we're involved there, through Gateway to Industry Schools program, certainly hit them up and you'll find us through there.
What is a digital twin?
Yeah, so a digital twin, it really, that's a very broad concept, but it's really a model of usually a physical object. So that's where the twin part comes from. There's a physical object, and then there'll be a digital twin, which is really a digital representation of a physical object that has a whole stack of digital data attached to it. So that could be materials information, it could be engineering information, information about its performance, its weight. It could include simulations or animations. So a digital twin, it's not a single thing. It's a digital object really that we use to really enhance our understanding or value of a physical object.
What is your favorite tech at work?
My favorite tech at work? Well, 3D scanning is actually really cool. So I guess we hear a lot about 3D print and additive manufacturing. The 3D scanning technology is laser scanning that lets you actually extract surface data and geometry, so we get to actually create a digital model of a physical thing. So I'd say that's probably the coolest tech we got here.
Is your job as cool as it looks?
Yes, it is. I'd like to say it is.
What's the coolest thing you've ever flown in?
Okay, sorry, I'm just going to have some water, one sec. The coolest thing I've ever flown in, I guess helicopters and flying helicopters is always pretty cool. So the machine that I showed in the presentation, the tactical helicopter for Victoria Police, would probably be up there. I do like flying and all sorts of stuff. So, you know, I guess for young kids out there that haven't been in a helicopter, vertical flight is getting, really, it's changing quite quickly. So probably like a lot of you guys out there, I enjoy flying drones and, you know, all sorts of little eVTOL stuff. So I'm looking forward to a future in flying some of the bigger multicopter and quadcopter stuff down the track.
Unfortunately, I think we only have time for one final question. Do you have employees who went to school on the Sunshine Coast?
We do actually, yeah, but that's a number we're really trying to grow. So, you know, a great thing about the Sunshine Coast here is we really have a, you know, quite a enjoyable lifestyle in and around us. We've got a few that have actually gone to school here on the Sunshine Coast and have either done trade studies or attended university here. That's a number we really want to increase into the future. So I guess for anyone that's out there that's really into tech that's here on the Sunshine Coast, we're really going to try and look after those future careers. But certainly we've got people from all over Australia as well as all over the world that work for us.
Thank you very much, Will.
No problems. Thank you guys a lot.
That brings our Tech Talks to a close for 2021. Sincere thanks to Will Shrapnel for highlighting the use of contemporary technology implemented at Helimods. For more information on careers in tech and the recording of this presentation, visit the ACS Foundation website. Stay safe.